Hey guys, this is 6.6. We're going to go through some solving radical equations and solving these equations with fractional exponents. And at the end of the day, no matter what the problem looks like, it's really about peeling the layers off of our x. And so if we look at, let's just say we've got 2 times the cube root of x minus 3 plus 4 equals 18. I honestly don't know what the answer to this is. It's probably some random decimal, but it's solvable. When it comes to solving for something like this, we need to remember we always go through SADMEP. We go through order of operations backwards. And so we're trying to peel these individual layers off in order to help isolate our x. So we always start by looking for addition subtraction that's not related to an exponent or a root. This cube root is an exponent. If you think of it as an exponent of 1/3, this guy right there, it's like in parentheses with an exponent on it. I can't touch it. But this plus 4, it could be removed. A lot of people on the day of the test, they want to combine the 3 and the 4, but that is unacceptable. We cannot do that because that 4 is not in the root. So if we move that, we're now going to have 14 equals 2 times the cube root of x minus 3. Again, we're going to peel layers. That was our addition subtraction. Now we're on to multiplication and division. I could divide by this too. I don't want to get into the exponent work until I've peeled everything on the outside of it off. That will leave me with the cube root of x minus 7 equals, x minus 3, I'm jumping ahead, equals 7. And now to get rid of a cube root. If I want to get rid of a cube root, I cube. I want to get rid of a 5th root, I raise it to the 5th power. So this will be a cube, but what I do to one side, I'm going to have to do to the other. This will give me x minus 3 equals 7 to the 3rd power. My calculator will tell me is 343. And if I add 3, I'm going to get 346 for my x. And that's pretty dang good. I like it. Now, there will be other ways these problems are written. They don't always look like they're in a root, even if they are. Another example, you might see something like x minus 3 raised to the 4/3 plus 5 equals 17. In a problem like this, we're still going to go through that SADMEP process of peeling layers off. And so we'd start with minusing 5 and minusing 5. And we'd get, x minus 3 to the 4/3 equals 12. Now comes the question, how in the heck do we get rid of a 4/3? Well, if we look over here at this step we did with the cube root, we had a cube root, and if we remember that a cube root is the same thing as a 1/3 exponent, we raised that to an exponent of 3. I'm going to write it as 3 over 1. If we think about raising the exponent to its reciprocal, we remember that our rule for raising an exponent to another exponent is called the power of a power rule, that we end up multiplying these two numbers together. If we multiply 1/3 by 3, we get 1. And we don't need to write an exponent of 1 on that parentheses, and that's why we were able to drop the parentheses altogether. Over here we have a similar problem. I want this 4/3 to go away, so I'm going to raise it to the 3/4, because that multiplication would produce 12 over 12, which is 1. And I'd be left with x minus 3 equals 12 now needs to be raised to the 3/4. Not times 3/4, raised to the 3/4, so I would have to take a calculator out, and I would actually have to type, let me clear that out. Let me move this thing. All right, I'd have to go 12 raised to the 3/4. 3 divided by 4. And that would give me 6.45. And if I add my 3, x will equal 9.45, roughly. You're going to get some decimals along the way. You'll get a lot of whole numbers, but you're going to have to peel those layers. SADMEP applied over and over again. There is one specific type of problem that we see towards the end, and I think it's really important that we take some time to talk about it. Let me grab this stuff real quick and get rid of some stuff. All right, so this last type of problem is really a pretty neat type of problem. It's something, it'll look something like square root of x minus 2 equals x plus 1. All right. So now when we have an x on the inside of a square root and an x on the outside of the square root, we're going to have to take a different approach. We can't solve for this x without also affecting that x. And it's a complicated process to try and think, how could I square root this x but not square root that x? It's a lot of thinking. So the approach that we take is to simply isolate a square root. So first off, is this square root by itself? It is. So then I could square that. But to do that, and that would get rid of that square root, that would leave me with x minus 2. Everything is beautiful except I have to square the stuff on the right. I don't have to square x. I don't have to square a 1. I have to square x plus 1. And when we square a parentheses like this, we really have to show it as a FOIL problem. If you're trying to cut a corner, you're always going to end up falling on your face. So be careful. This just becomes x squared plus x and plus 1. Or I have x minus 2 equals x squared plus 2x plus 1. Because this is quadratic in nature, I'm going to have to solve it by moving everything equal to 0. So I'm going to minus an x, and I'm going to add 2. This would give me x squared plus x plus 3 equals 0. Now I want to be upfront with you. On the homework, we're going to stay with pretty simple ones that will actually factor really well. This is not an example of one that factors really well. This would require the quadratic formula. It's totally doable. But what I really want to talk about is, let's say that we get the answers. We go through the work and say we get the answers of 2 and negative 1, something like that. It's entirely possible that those solutions aren't valid. We call them extraneous solutions. Sometimes they're extra answers, and they're definitely erroneous or wrong. And so we call them extraneous. We want to get rid of those extraneous solutions by confirming whether they work or not in the original problem. Here's what really happens. When we square a square root, we hide whether that square root was positive or negative. Remember, when we work with the square root functions in the graphs, we always just looked at either the top half or the bottom half. But when we square the square root, we're creating a new function that has both of them. Okay? We're melding the two of them back together. Well, if I was only talking about the top half and my graph looks like this, I have one solution there, one solution there. But maybe this solution isn't part of the original problem. It'd be a part of the negative square root of x minus 2. So we have to confirm our answers in the original problem. So you'll see that in the video. Whenever you get an answer, when you had to square an x on the outside and inside of the square root, you're going to have to go through and check your answers. You'll see those towards the end of the assignment. I'll just jump down there now. Right here, like 34. We have an x on the outside of the square root. We have an x on the inside of the square root. We're going to have to use a quadratic formula or factor to solve, and we're going to have to check our answer. Let's take a quick second. I know I'm going to go through these I go through these with the the notes, but let's just look at 36 here. If I square this side and square this side, I get x squared equals 16x plus 225, because it canceled the square root over there. If I set it equal to 0, it's x squared minus 16x minus 225 equals 0. I'm going to factor this. I got to figure out what factors of 225 subtract to make 16. Now I might need a calculator for that. I'll show you a really cool trick. If we go to y equals, clear it, and we take 225 divided by x, and I'm just going to go to the table. This will give me options that multiply to make 225. And right here, you see the 9 and the 25? Okay, those are 16 units apart, which the difference between those would be 16. So if I use a 9 and a 25, in order to get a negative 16, I need negative 25 and positive 9. This would tell me that my x could be negative 9 or positive 25. For me to be sure about those, I'm going to need to confirm it in the original problem. So let's imagine I had negative 9 equals the square root of 16 times negative 9 plus 225. Well, I need to know what the square root of 16 times negative 9 plus 225 comes out as 9. But there's a problem, because it's not supposed to be 9. It's supposed to be negative 9. So that negative 9 is a throwaway answer. Let's try the same thing with the 25. If I just come up here, and instead of a negative 9, I'm going to put 25, gives me 25. Would 25 equal a positive 25? The answer is yes. So this answer here, negative 9, gets rejected. I'm only left with 25. That's what we mean by check our answers. We've got to make sure that they actually work, because sometimes we get answers that are wrong. And there is a possibility that both answers came from the wrong side of the equation. I could have two bad answers, but we have to check. That's, I guess, the point. Be thorough, be convincing. Good luck. I'll see you guys in class. Shoot me a message if you need some help.